Hi everyone. Today we will start with the intro to Bayesian probability. First, let us discuss the probability. So probability denotes the possibility of any event to occur. So for example, if we have five blocks, three red and two blue, then the probability of selecting a red or blue block will be. So these are the five blocks and three red and two blue. So the sample space for this question is five. Sample space denotes the total number of objects in any environment. So the probability of having a red ball will be three red balls upon five total blocks, which gives us 0.6, 60%, and simultaneously for blue, 40%. So now let us understand what are the different probabilities. So first we have marginal probability. Marginal probability defines as an event irrespective of the outcomes of other random variables. So marginal probability is only dependent on that event. Then we have joint probability, which deals with two or more simultaneous events, example P, A, and B. So, for example, tossing a coin and rolling of a dice. If we have these two events happening simultaneously, then we have conditional probability, which is defined as one or more event, but given the occurrence of another event is already happened, what will be the probability of next event to happen? So, to understand conditional probability, let us start with an example. So suppose a study is going on in a rainy city, assessing changes related to rainy day and carrying umbrellas. So researchers are trying to find a relation between rainy days and umbrellas, and these were their findings. So probability of umbrella with rain, these two is 20%. Probability of having umbrella with no rain is 40%. Probability of rain in a day is 25%, and no rain is 75%. So we have to find the probability of umbrella when there is no rain and probability of umbrella when there is rain. So P umbrella given rain is already happened is given by the intersection of P umbrella with rain and P of rain, which gives us the expression 0.8% or 80% probability. Similarly, the probability of umbrella with no rain is given as the probability of umbrella with no rain, intersection of no rain upon probability of not having a rain, which gives us the expression 0.4 upon 0.75, which gives us 0.53. So now let us understand the Bayes theorem. So Bayes theorem is derived from the conditional probability containing two different conditional probabilities. The expression for the Bayes theorem is PA by B given PB given A into probability of A upon probability of B. So in most cases, we don't have probability of B given. So for that, in case if probability of B is not given, we can calculate as the law of total probability says that if for any event to occur, the probability will be PBA upon into PBA into PBA naught into PA naught. So PA naught is just the probability of event A not happening. So which will be 1 minus P of A. So which gives us the final expression of our Bayesian probability as this. Substituting the P of B in the denominator, we have PB by A into PA. So now let us understand Bayesian theorem with an example. So before that, we also want to discuss the different terms in Bayesian probability. So this is the likelihood that probability of B being true given A is also true. And similarly, posterior is just the reverse of likelihood. We also have prior, the probability of A being true. This is the knowledge and marginalization, probability of B being true. So for the example, we have two ones containing four red, three green balls, and three red, five green balls. One ball is drawn at random from the first turn and transferred into the second one. And then a ball is then drawn from the second one and it turns out the ball is red. So what will be the probability that the transferred ball was green? So now we have two events. Event A, the ball transfer from one urn is red, or the ball transfer from one urn is green. So probability of such an event to happen is PA 4 upon 4 by 3, which gives us 4 by 7, and PB gives us 3 by 7. Now let us X denotes the event that red ball is transferred from the second urn after A and B occurred. So probability of X to happen when A is given. So if A red ball was transferred from first turn to second, then now we have four red balls and five green balls in second turn, which gives us probability of selecting a red ball 4 by 9. And if first green ball was transferred from first turn to second, which gives us three green balls upon 3 plus 6, three red balls to select the probability of red ball 3 upon 3 plus 6, which gives us 1 by 3. So now the event X occurs if any of the mutually exclusive and exhaustive events A1 and A2 occur. A1 refers to A and A1 refers to B event. So using Bayes theorem, PA by X is given by this expression. Substituting the value of every expression, we get 4 by 7, which is the probability of selecting a red ball from first turn to trans, and 4 by 9 is the when red ball is selected, what will be the probability of drawing that red ball from second turn. Similarly, 3 by 7, selecting a green ball, transferred a green ball from first turn, and probability of if green ball is transferred, what will be the probability of selecting a red ball from second turn? This is 3 by 9. So in total, this gives us this expression 16 by 63 upon 25 by 63, which gives us 16 by 25 or 0.64. So 64% is the probability that in this question, when second ball is drawn, second ball is drawn and it is found out to be red, then what was the probability that the first transferred ball was green is given is as 64%. So this was the introduction to Bayes theorem. In next lecture, we will be covering more details about Bayes theorem, and see you in the next lecture. Thank you.